Hi everyone. This lesson is I'm going to demonstrate the solution to question 7 on the QCAA Sample IA2 paper. And here we have a lovely table of data. So the velocity v of an object varies with height h in metres from which the object is dropped, as shown by the table here. It says one of the values of v is incorrect. They do tell us this though. They say log v is a linear function of log h. So that's good. And we are to use a graphical method to locate the correct the value of v. So one of these v's is out of place. This is a classic tech active type question. So the first thing I'm going to do is reach for my calculator. And this one I'm going to use the statistics app because I can store lists of data. Now I've already entered the values here. These are the values of h, so my first column, list 1, and these are the values for v. I've even put little labels here using the text, the alpha key. The labels are not strictly necessary. It just helps me remember what's what. Now if I wanted to have a quick look at the information there, I could do a graph. Don't forget to always check the graph settings. So my first stat graph uses list 1 versus list 2, right? My second stat graph is list 3, list 4. You can change those just by going here and selecting different lists, but I like to have that set up before I go into the exam. So list 1 and list 2, that would be graph 1. And it's a bit hard to tell from this because it looks like it could be a curve. I suspect that one's the one that's out of place, but I'm not going to go with that. I'm going to go with log v and log h like it said. So I'll put a label in here. This one I want to be log of h. Now that's just a label. If I want the machine to calculate these for me, I have to have the cursor at the top of the list, and then I'll do the same thing, log, but this time I'll refer to it as list 1, log of list 1. And those are all the values, logarithm 5, log 25, log 45, so on. I'll do the same over here. I'll just put a little label here, that's the log of v. And now up to the very top, and I'll write logarithm of list 2, because the v velocities are stored in list 2 there. There they are. Now graph number 2 is the one I'm going to pick because it's set up to look at log h on the horizontal axis versus log v. So let's go to graph 2. Now that's looking pretty good, and I think that one is out of place. Yes. If I was to do a straight line fit here, ax plus b, it's a pretty good fit, 0.997. That's good. But you can see that this data point, the wrong one, is included, and it's probably dragging my line of best fit down a little bit compared to what it should be. If I'm really going to correct this, I need a line of best fit that doesn't use that data point, which is wrong. So I've identified it. Now I probably should write something down to explain to the examiner what I've been thinking. So this is what I would do. I would do a very quick sketch. Now the horizontal axis was the log of h. The vertical axis was the log of v. I had data points that were almost a perfect straight line except for that fourth one, and then there was one there. I'm going to try and just freehand a straight line through there. Oh, close enough. I will identify this one as the suspected error. Now, what I really want to do is get a line of best fit just using the form good data points. So here I go. Where's my calculator back again? So I'll just go back to here. I'll go back to here. Now the fourth one was the problem. That's that one. So I'll have to delete that data point. And then I better go over and delete the corresponding value of v, there it is. Now, unfortunately, it's not quite like a spreadsheet. I will have to recalculate the log of list 1, and then I'll go over here and calculate the log of list 2. Now there should only be 4 there. You see how those last ones have disappeared. If I go back to graph number 2, beautiful. Here's my calculations, then linear, and I'll choose ax plus b, and there's my a value, there's my b value. My correlation is now way better. I mean, last night it was 997. Look at that, it's almost perfect. So I'm just going to write some of that information down. Now I will say over here that I had I used the stats, and then I did a graph, and then I did a calculation. That was the menu, and then it was a linear graph of the form ax plus b. That's the one that I chose. Now, what did the calculator tell me? Well, you see, my graph, if I was to write y equals ax plus b, the a value, the y value of my graph is log v, isn't it? So that was the logarithm of v. Now the value of a, I won't write it all down, it's pretty much 0.500 if I was to round off to 3 decimals. The x value of my graph was log h. And the value of b, the intercept, off my calculator screen was 0.904. 0.904. And I would probably want to say that this was excluding the erroneous data point. So it's all about communicating to the examiner what we were thinking. It doesn't have to be an essay, but we don't want to leave thoughts like that in our head. The examiner wouldn't know that my calculation was based on 4 instead of 5 data points unless I tell them. Now, I'm going to try and correct the value. It says one of the values of v was, I think that was the incorrect one. That means I believe that the value of h was actually 70, don't I? So I really need to let h equal 70 and then use this formula to calculate v. So here I go. The log of v should be 0.5 by the log of 70 plus 0.904. Now, I'll show you a way to use the technology to do this without rounding. You see how these numbers that I'm interested in are A and B. Let's just pop back to the normal calculating screen. I want to see the variable key. Now I was in the statistics app, so stored under this stat menu, and then I was in the graphing area. I've got stored the value of A. If I just hit enter now, you'll see that it's that number that was on the previous screen, the one that I rounded to 0.5. So I would like to use that value, multiply by the logarithm of 70. I might just put that in brackets, the logarithm of 70. And then I want to add on the 0.90, but that was the value stored in memory B, wasn't it? So let's just do that, and I get that the answer to my calculation is 1.825. No rounding at all. So here I have the log of V is 1.825, Of course, I want v, remembering that common logarithms are to base 10. This would be 10 to the power of 1.825. So 10 to the first power is 10, 10 squared is 100. This is going to be between 10 and 100. Now again, I can use my calculator for this. I could literally go 10 to the power of the previous answer. It is 66.9. That's close enough, I think. 66.9. And that makes sense. Now, the units for V were, I think, meters per second. I better write meters per second. So have we answered the question? We have used a graphical method? Yes. Have we located the error? Yes. And have we corrected the value of V? Absolutely. And so that's the end of this installment. Thanks for watching.